Okay, so let's go ahead and get started. Welcome everybody. Thank you for joining again. In this session, Sheriff will present a fast-paced introduction to the exciting new world of blockchain technology from a perspective of software developer. We will cover the basic concepts introduced by this new technology, often called Web3, before diving into several practical examples, all the way down to the code of smart contracts. So welcome, Sheriff, everybody.
Nice, thank you. Yeah, Sharif, Sheriff, it's all good. My best friends call me Sheriff, so no worries. Okay, so thanks everybody for coming, really appreciate it. We only have about 30 minutes here, so we're not gonna be able to dig very deep at all, but I hope to give you kind of a whirlwind tour of the platform, and then I can share these slides with you. So if you wanna take a look at the slides at your own pace, sometimes I like to do that, then this is the link. I'll just share it right here in the chat. Have at it. You should be good to go. And that should give you view access to these slides. And let's just dig in. So I'm noticing here like some people coming in. Ben, are you able to admit them, or do I need to?
I got it. You focus on your presentation, and I'll let you go in.
Okay, yeah, sounds great. So there are a few chapters in this presentation here. It's a new one that we've just kind of recently worked on. It includes a summary and a bunch of slides from previous presentations. So if you've seen any of my other talks, some of this will be familiar, but hopefully we'll have a chance in real time here to ask questions and answer them. I'm going to try and take up maybe, I don't know, 15, 20 minutes max, and leave the balance, 5, 10 minutes for questions. So if we talk about kind of, what is this stuff? Why are we even talking about blockchain? Why is it even interesting? Here are three, perspectives on this. So historically, if we start with that, just from a historical perspective, we're at this kind of this new thing, this edge of this new thing, and we can take it back, 60 years ish, and talk about sort of Web 0 as being the connected web, where you have computers shrinking from the size of a house to a bus to a desk to, I don't know how many computers I've even got around me right now. I'm not even sure if my Apple headphones have a computer in them. I suspect they've got some sort of processing in there for power management. So we've got computers all around us right now, and this sort of thread of Web 0, sort of the infrastructure and things that have been connected, has been going on for a long time. So layering then on top of that, we talk about the readable web, which, I don't know, 40, 50 years ago was basically a couple of computers sharing some, company documents or some university research documents, bulletin board systems in the 80s and 90s. And then, now I can basically ask Siri to tell me the weather, and Siri will respond, read the web and respond back to me with an answer. So that's kind of the readable web. And if you think about sort of how sophisticated that's gotten, then it's going to continue to get better. The writable web, so us putting back into this system where it's not just kind of like a broadcast medium. Maybe in the 80s with bulletin board systems, again, we could talk about that. And then 90s with like personal sites, GeoCities and the like. And then up to today, I can basically install an app in 2 minutes on any modern smartphone and start streaming live to TikTok or whatever. That's the writable web. And again, just a massive shift in the way that we use this technology. And then the trusted web, sort of this idea that we can share secrets in public, has been, some people think, very recent, but it's actually been around for a while, 40, 50 years, starting with a paper by Diffie, Hellman, and Merkel in maybe 76, I guess, whenever that was published. Doesn't matter. And over the next 10, 20 years, lots of different experiments in terms of how we can share secrets in public without revealing who we are, and without other people being able to lie about those secrets or take them or whatever it is. So public private key cryptography is what I'm talking about. Today, what this looks like is blockchain, basically the ability to have a private key like a password, and to establish that we are the owner of an account without any risk of anybody tricking us or faking that identity. So that's this kind of 3 or 4 layers that are coming together at present. And so what we get with all of these layers, of course, the trusted web, depending on our ability to read and write data, to stay connected. And the fact that all of these computers around me are actually connected and online, that's all a prerequisite to the layers above it. And so today we get things like DAOs, decentralized autonomous organizations, where we can write smart contracts and basically have them manage our interactions. And token economics and mechanism design. There's a great YouTube video linked right down here at the bottom, YouTube series, like maybe 10 hours worth of short videos explaining token economics and how it might work and affect our daily lives. And, if we wanted to sort of dial it up to 11, we could talk about total disintermediation, civics API, borders API, banking API, humans API. Who knows how far it'll go? We'll see. I mean, there's no way you could have imagined in the 40s and 50s. I wasn't around then, but there's no way you could have imagined what we have today around us. Even, 10, 20 years ago, it would have been hard to imagine the access that we have today. So maybe this is obvious for some of you, but if you haven't considered it, there's a lot of this stuff that is sort of has historical precedence and we've been sort of driving towards where we are today. And so this isn't going to stop. It's not like things are going to slow down, I expect. Maybe in hardware they will, but in software, we're maybe just at the beginning of some real innovation here. You may have heard of like the no code or low code movement, where you can very quickly build an application without even knowing how to program. You just need to know how to, say, control a spreadsheet or something like Excel. So a lot of interesting things there. And so a second lens here, just to kind of go back to this, kind of a useful analogy. If we talk about, what is a blockchain? If we think about sort of reality, I have an apple, and maybe I give it to you, right? And then you eat it. That makes sense, no problem. Any child can understand that. And also, if we reverse two of these pieces, the story doesn't make any sense at all. You can't eat it before I give it to you, right? It's a bit sort of nonsensical at that point. And so that is really at the core of the question of sort of what is blockchain. It's this kind of way of putting structure to digital reality, where like one thing happens after another. Okay, and so here is a picture. I don't know if it's a blockchain or just a graph or whatever. It doesn't really matter, but there's a picture, and let's say that this is a blockchain, and at some point, maybe the third step, whatever that means, Alice transfers $100 to Bob, and then a little bit later, Alice transfers 10 to Bob. And so we might ask, like, what's the reality in this? Because we have multiple copies of the same sort of thing happening around the world. We have in Bitcoin, Ethereum, Near, for example, we have dozens or hundreds of computers, maybe thousands of computers that are all agreeing on consensus, on the sort of the ground truth. What is the truth? And so at some point, you have to be able to ask the question, what's actually true? Did Alice transfer $100 to Bob, or did she transfer $10 to Bob? And so we basically have to pick what that truth is. And so in this case here, we're picking this blockchain here as being the truth. And so one perspective on this is that you can think of blockchain as this clock that ticks in blocks instead of seconds or minutes or hours or times around the sun, whatever. It just ticks in blocks. And if something happens in block 1, then in every subsequent block, 2, 3, 4, 5, that you can count on what happened in block 1. Nobody has the technology or the resources today on the planet Earth to change what happened in block 1. Can't be done because the network is economically incentivized. It's more expensive to lie than it is to tell the truth. And so what you get is this determinism. Similar to the apple. I can't just make an apple out of thin air. I've got to grow another tree and pick an apple from it. And so in this way here, if I move money, let's say, or ownership of an NFT or something in block 1, then the rest of the history of the chain, for as long as it lasts, is that block 1 sort of event is considered to be true. And so if that makes sense to you, then welcome to the new reality that is this world of the trusted web and the open web, Web 3. That's basically what we're talking about. It's a profound thought when you kind of follow it to its end, or at least explore it a little bit. And so with Bitcoin, we have these cryptographically verifiable transactions, decentralized storage, public ledger. These are some of the words you may have heard with Bitcoin. Ethereum, on top of that, put a Turing-complete virtual machine. Just means that you basically a Turing-complete machine is a machine that can simulate any other machine. And so the idea here is that you basically put onto this layer that is truth, you put the code that will simulate anything, a smart contract or NFT or whatever it is that you want to put on there. And then the data inputs and outputs also get put on the same layer. So you can guarantee the truth of the code and the truth of the inputs and outputs and data. And so on top of that, you can build whatever you want. And that's what people are doing today. DeFi and so on. And so the problems with Bitcoin and Ethereum is that they're expensive and they have low throughput, they're hard to scale, a little bit slow. And so several different groups are working on trying to address that. And it's all by parallelizing something, doing work in parallel. So what Near does is we have a sharding approach to solving this problem. We've sharded compute and storage for the first time. And so that's the innovation that is the Near protocol and Nightshade and some of the other technologies that we have. You can read about more about it at near.org. But basically we take a transaction and we put it in the right shard. And then depending on what other accounts and contracts it's working with, we may move it from one shard to another. Polkadot parallelizes through parachains. Solana parallelizes by timestamping using some timestamp kind of leader that receives all transactions, then parallelizes them and merges them once they've been processed. And Avalanche parallelizes through specialization. So they have 3 different kinds of chains, one for value transaction, one for executing arbitrary code, things like that. So everybody's kind of taking the same approach of parallelization, but the difference is in the details. All right. So from the user's perspective, what does this mean? We have art on chain. You can sell property in virtual spaces or art. You can have different people who earn a living actually. In fact, Paris is one of the leading demonstrations of NFTs and digital art on the Near platform. You can see here a screenshot from their environment. And then we have games as well. So esports, politics, startup derivatives, whatever. There's a sort of prediction market story on the left-hand side, or a little bit more frivolous kind of game assets that can be bought and sold, or maybe community-based drawing, where people are kind of competing for control of these pixels in a drawing on Berry Club. So lots of different things there. Not all of these are built on Near, by the way. Berry Club is, and Paris is in the previous slide. And programmable money you have. So here is Kickback, an example built on Ethereum where people register for an event and then everybody kind of pays a deposit. And if you don't show up, you lose your deposit. But who gets it are the people that show up to the event, actually. So that incentivizes attendance. Once you register for an event and you pay your deposit, you're incentivized to go there because other people are going to basically pay you to be there if they can't make it for some reason. That's a pretty interesting thing. And imagine how many sort of banks and lawyers and contracts you would need to put in place to get something like this to work. But in fact, Kickback is just some contract code running on Ethereum. And so there's some pretty interesting ideas here. There's a couple of others here that get a little bit more complicated, like this curation market, Everest.link, I think this one's called. And basically here, you put some kind of link up like Wikipedia, and you say, here's $10 that says this link is true. And then someone else might come in and challenge that and say, I don't think so, actually. It's outdated, or it's irrelevant, or it's wrong. They put up $10 as well. And then there's some committee that reviews on some regular basis to see sort of voting, which one's right, which one's not. And then depending on who is deemed by this committee to be the winner, will take most of that money. Some of it goes to pay the people who are doing the voting to decide who's right in the end. And then maybe the most sophisticated example I've got here is from the graph, where they have all these different roles: indexers, curators, delegators, consumers. And basically they've set up the system that allows you to very easily interact with data that is on the blockchain, on various different chains that they integrate with. As a developer, it's fantastic. And to get people to behave well in this system, they have this GRT, this kind of graph token that they reward people in you get rewarded for behaving correctly, basically, for indexing the right kind of data, curating the right kind of data. You can even kind of delegate to support people to say, this person knows what they're doing, and I support their work, or this data source is a good one, I support what they're doing. So lots of interesting things there in terms of the economics and the structure of how this all works. All right. And then from a developer's perspective, we don't need to dig into kind of the details of this. We don't need to think about all the details of like what a car is, for example, right? All these sort of mechanical engineering details of a car. We could just like drive it. So as a developer, if you're wondering, what can I do with Near? You don't need to get into all the details. You don't need to get into all the details of knowing how a battery chemistry works, for example. You can just use a battery. You can put it into your electronics and use it. And so in the same way, there's a bunch of details around Near, the validators and consensus and proof of stake and sharding and all these other details that you might be tempted to get into. I would suggest wait a week or wait a month. And today, just start learning how to build things. you can actually do that without spending a lot of time, reading research papers. You can just learn to start building. And if you're a developer with 1 or 2 years experience, probably build something this week if you wanted to. Next week, I guess it's Friday now. All right, and here's kind of the story about Near, is that it is cheaper, faster, and easier to use from a development perspective, from a production perspective. I'm not going to read these out to you, but you can scan them yourself or pause the recording and read through it if you like. And at a high level, this is basically how it works. There's this blockchain layer, your application. There's an RPC interface, like an API. You can think of it. It's not REST exactly. It's still JSON over HTTP, but it doesn't conform to REST if you're familiar with that. And then we have a wrapper called Near API.js. Your application communicates with that wrapper, as do all of our applications. We eat our own dog food here, so we're committed to maintaining the quality and integrity of this library. Near Explorer, Near Wallet, Near CLI, these are all sort of parts of the platform that we use exactly the same tools and tech stack that we ask you to use for your applications. And then at a low level, we can sort of dig into a few more things here. I've got a lot of slides in this deck. We're not gonna have time to cover all this stuff, obviously, but maybe just to kind of give you a quick peek into some of it, there is inside of the sort of the system, how it works. Your application, step 1, communicates with the blockchain layer. Step 2, step 3, there's a virtual machine, spins up, runs your code, comes back with the response. If you're not a developer, don't stress. It's basically, this is how the system is communicating at a low level. What the state storage looks like is this kind of key value pair, a little bit of metadata, a little bit of data. And you actually get this this kind of key value pair thing going on inside of the blockchain storage. This is what your data looks like when it's being stored. We have also accounts that are user-friendly, human-readable names, really easy to understand and reason about, and sub-accounts and some other nice bits there. We have 2 kinds of access keys. If you're familiar with Ethereum, where basically each account has 1 key. We have unlimited number of keys. Function call access keys let you call functions like this particular thing. Full access keys let you do all this stuff here, including create accounts and delete them, add keys, delete keys, transfer money on behalf of the account, stake on behalf of the account, deploy a contract to an account, and so on. So there's a lot more here that you can dig into if you want. It's 20 minutes after the hour. I want to make sure that we end on time today. So maybe I could just stop there and leave it open for questions. If anybody has anything that they'd like to ask in the chat, I'll just type it out. Feel free to type it in right here, and we can dig into that together. All right. So any questions, any comments, anything you'd like me to review, or and then AssemblyScript and Rust. Here are the 2 programming languages that you would use basically to build on Near. You write your contracts in this code, and then you deploy it, and then you would write a front end using whatever technology you want. It could be mobile, it could be React, Vue, Angular, Svelte, whatever you're into. All right. So can we open it for questions? Any questions? Any comments?
Yeah, I have a quick question actually.
Sure. Mm-hmm.
So what are some cool things being built on Near right now, just for example?
Yeah, so there is a URL here called Awesome Near, and this sub URL here will show you the trending piece. So there's a few things. Aurora is maybe the most exciting piece that we've got recently released. So the team here has actually built a couple of technologies they put together where we have the Ethereum virtual machine running on Near. So you can take a Solidity contract, you can deploy it to the Near platform. It'll run there, uses ETH as a native token right inside of Aurora. And then you benefit from all the speed improvement in Near, the cheaper transaction costs, significant benefits there. So this is a fantastic example here of something that a very capable team has put together, and you can go and check that out if you like. Flux is a prediction market. We saw some screenshots of that earlier. Octopus is kind of a collection of several different kinds of networks working together. Ref Finance, a finance application automated market maker where you can kind of do trading and so on. Sputnik DAO, a decentralized autonomous organization with lots of great features. So tons and tons and tons of stuff here. I mean, I don't know what, 20, 30 things here in this list, and more coming all the time.
Awesome, that sounds so cool, thanks.
Yeah, thanks for asking. Any other questions, any other comments? Feel free to write about them here. or just take, unmute your mic and ask if you like, no problem.
I guess I'll go ahead and ask another one. If
Yeah, please.
Up. Is there any extra functionality for NFTs?
So extra functionality for NFTs. When you say that, I'm not sure at what level to answer you. So this is a list of 20 applications built by Matt Lockyer, who is one of our lead devs in the developer relations team. And there are a couple of sort of major launches that have been associated with this, including NFT hip hop that was recently released, and a few of these other sites. Some pretty interesting examples here. Generate, for example. I'm not sure what the URL is for Generate. I should really have these top of mind. Let me see if this will bring it back. Yeah, so here's an example of like generative art. You can basically customize your own formula and kind of release the NFT, and then you add a little bit of dynamics in there, and kind of it'll go and add that layer, and then once you sort of add your layer, you can go and sell it, some modifications, some derivative work. So that's kind of at a kind of eye candy level of the answer. Maybe for non-technical people who want to see cool stuff on the screen, you can do whatever you want with NFTs on Near. There's nothing kind of stopping you there. And this is the mother lode of application examples, this Near apps that I shared earlier. But in general, when you talk about an NFT, what is it? If you imagine like a kind of a, I don't know, like a betting pool at the office, where like you've got an Excel spreadsheet and everybody's got their name, in one spreadsheet, one row, and you've got whatever details about your name are. That is basically a database, right? Where you have a single identifiable row that represents one entity in the system. And that's what an NFT is basically that one row, but instead of a spreadsheet that's sitting on your laptop that you can edit whenever you want, it's a record that's sitting on the blockchain where the incentivized truth is, reigns supreme. And so you can't lie about who owns an NFT. And if you buy it or sell it, then that sale or purchase or whatever is final. And so that's really kind of the difference. And then what the NFT does, customizing it, whatever it is, you want to layer it, you want to make it dynamic, you want to make it whatever it is, that's just a matter of putting some code into the contract. And because we use a Turing complete environment, the AssemblyScript and Rust are Turing complete languages with their own communities, you can basically do anything you want with software. So there's no real limit on what you can do with NFTs. Does that help?
Right. Yeah, totally. Thank you so much.
Sure. All right. Any other questions? Any other comments? We've got about 5 more minutes.
That's all the questions we have. I don't think we need to take up any more of your free time, Sharif.
Yeah, it's all good.
Yeah.
I'm here to help. Yeah.
Thanks again for coming in.
Yeah, thanks for having me.
Yeah. And then this recording will be available to like rewatch and stuff like that in the Discord. Just shoot Connor.
Just a question, Sharif. Where's the best place for people to find you and to learn more? Yeah,
I mean, I would say Near chat is an invitation to our Discord server. Thousands of people from the community, developers, entrepreneurs, who are interested, people internally. Yeah, Varun, that's the near.chat is the invitation to Discord, right? So that'll get you there. And then near.org, learn is a good place to get started as well. It's got a nice list there of kind of introductions and so on. And we're always kind of adding more examples and more opportunity for you to connect. But if you want to find me, just look for my name, near.chat. You'll find that to be an invite to Discord, and you can just ask for me there. Yeah.
Amazing. Thank you. And for
Sure,
everybody in our hackathon Discord, we have those resources pinned as well.
Nice. Okay. Thanks so much for having me. Really appreciate the invitation. Ben and Connor, thank you so much. Good luck, everybody. Have fun in the hackathon.
Thank you.
Thanks so much.